All right, so the first page is all about graphing these, and you have one in each form. So the form for number 1 is vertex form. That's y equals a times x minus h squared plus k. The vertex will be at the point hk, and then you make a t-chart. Okay? That's our plan of attack on this one. So what is the vertex for number 1? -1, -2. Don't forget the h is always the opposite. So if they're adding 1, our vertex will be at -1. If they were subtracting 1, it'd be a +1. Okay? And then k, the sign always stays the same. All right, so I know I will have a point at -1, -2. Now, A is positive, so I know this should be opening up. A is +1. So that's kind of a good way to stop and check once you have a graph to see if you did it right. And our axis of symmetry is the line through that x value. Okay? So if you want to make a little note, x equals -1 is our axis of symmetry. All right, now I need some more points. So for our x values, we plug the x's in, we find the y's, and then we use that property of symmetry to get the other side of the parabola. So I want to go either 2 x values to the right of my vertex, 0 and 1, or if you want to get crazy, you could go the other way. You do -2, -3. We usually pick the smaller ones, and 0 is always a really good one. So I'm going to go with 0 and 1. So y equals 0 plus 1 squared minus 2. So that's 0 plus 1 is 1, 1 squared is 1, 1 minus 2 is -1. So now I can go graph that. So 0, -1. And then it's symmetric. So if I'm 1 to the right of my axis of symmetry and I am at -1, I can go 1 to the left and go down to -1. Okay? Now I'm going to plug in 1. So y equals 1 plus 1 squared minus 2. So that's 2 squared, which is 4. Minus 2 is 2. So now I'm at +1, +2. That's 2 to the right of the axis of symmetry. So I can go on that same y value 2 to the left and put a point.
Where do you get the
2 plus 2. Or sorry, 1 plus 1 is 2, and then 2 squared is 4. All right, now that I have those points, I can connect them, and I am good to go. All right, questions? All right, the next one is in intercepts form. So off to the side, I will remind you what intercepts form looks like. Okay, so here's what you need to know about intercepts form. It is in that form, y equals a, and then in parentheses, x minus p, another set of parentheses, x minus q, where p and q are our x-intercepts. So that's where it touches the x-axis. We still need to find the vertex. The vertex is smack dab in the middle of those points. So we average p and q. So add p, q, divide by 2, and then plug that back in to find the x value of the vertex. That'll give you 3 points, and that's enough on this form. Okay? So what's P and Q here?
1 and negative 3.
1 and...
Oh, so you don't switch.
Hold on. It's negative 1 and...
Oh, yeah.
I'm going to put and so you guys don't think that that's an ordered pair. So it's, yes, it's the opposite on both of these. Which, when you think of the zero product rule, like if we set this equal to 0 and found the intercepts algebraically, we'd use the zero product rule. What would make this 0, what would make this 0, and the signs end up flip-flopping when you solve for x. So that's kind of where this comes from. So if I set x plus 1 equal to 0, I'd get negative 1 as the answer. If I set x minus 3 equal to 0, I'd get positive 3 as the answer. So you got to switch those signs. All right, so that's where I'm touching the x-axis, at 3 and at negative 1. Now, to find the vertex, you can put a finger on this one, a finger on this one, and just like jump your way to the middle. Or you can add these and divide by 2. So I'm getting 1. And then we plug it back in to find the y value of the vertex. So y equals 1 plus 1, 1 minus 3, 2, negative 2.
Y equals negative 4.
Okay, yes, but I was told to wait a second, so I'm waiting a second.
Sorry.
It's okay.
It was at negative 3.
It's the opposite of what's up here. So since it was x minus 3, our intercept is positive 3. Since it was x plus 1, our intercept is negative 1. And then we use these values, and it's whatever's right in the middle. So algebraically, you can find the average, or graphically, you can just kind of count the jumps till your fingers are touching, which on the tiny graphs is kind of hard. Maybe more like the tip of your pencil. All right. So 1, negative 4 is my vertex.
So you plug in the x-intercepts to find the vertex?
You find the average of the x-intercepts to find the x value of the vertex. And then you plug in the x value of the vertex. If you're struggling, if you know how to find the intercepts but you don't know how to find the vertex, just look at the graph. It's right in between them. So like these are 4 jumps away from each other, right? So just jump them each in 2 and you end up right in the middle at 1.
How do you do this?
Let's give everyone a little time to process. All right, I'm going to get going on the next one. So we have y equals ax squared plus bx plus c. This is standard form. For standard form, that's where we find negative b over 2a. That's the x value of the vertex, and then you plug that back in to find the y value of the vertex. And then you use an xy chart. So we have negative b, so negative 4 over 2a. So negative 4 over 4, so negative 1 is the x value of the vertex. When you plug negative 1 back in, don't forget when you square it, it'll become a positive 1. Then multiply it by the 2. Whoops. So that'll be 2 minus 4 minus 1. I'm getting negative 3.
Negative 3, that's right.
So -1, -3. All right, and this will be symmetric through that point. So if you want to note that as well, our axis of symmetry is that x equals -1. I am way out of space, but what do I do next? I think your writing's a little smaller than mine, hopefully. All right. Now we need an XY chart. You can go 2 to the left or 2 to the right, depending on which one's easier. 2 to the right. So I'm going to go 0 and 1. When I plug 0 in, I get 0, 0, -1. And then it's symmetric, so I'm 1 to the right of the axis of symmetry. So if I go 1 to the left of the axis of symmetry, I'm still at -1 for my y.
Wait, it's 0, -1. I thought it was 0, 0.
I got 0, -1 because it's 0, 0, -1, right?
Oh, yeah.
All right, when I plug 1 in, this one I will have to write out. So when I plug 1 in, that'd be 1. So that'd be 2 plus 4 minus 1. Am I doing that right?
Yeah.
2 plus 4 minus 1, so 5. So 1, 1, 2, 3, 4, 5. Okay, so 2 to the right of the axis of symmetry, I'm up at 5. So 2 to the left of the axis of symmetry, I'm still up at 5. And that is enough. Whoa.
I'm hungry.
Okay, so the next one. It says to solve the quadratic equation. You know 3 ways to solve these. Actually, you know 4 ways to solve these. Anyone remembering? The easiest way is to factor. Okay, so factoring is probably the go-to at first. Well, that's a way to factor. You could complete the square. You could use the quadratic formula. Or one like number 8 where there's an x squared term but there's no x term, you could take the square root of both sides. So there's a lot happening here. It's kind of start with the easiest one and go from there. Here I can list the ways. So you can factor. You can complete the square. Students from experience tend to avoid number 2 unless the directions say complete the square. Number 3 is the quadratic formula. Number 3 is like the when all else fails, that one's always going to work. So if you can't factor, if you're like, I don't like completing the square, then quadratic formula will work on every single one of these. Okay?
Is it weird that
And then number 4 is to take the square root of both sides. That only works when you have an x squared term and no x term. Okay? So those are the 4 go-tos on this.
We're gonna factor.
Careful with factoring, because when you factor, it has to be in this form. Or difference of squares.
Has to be.
Okay? So like number 6, you gotta, well, no, number 6 would be fine to factor. Well, no, I wouldn't factor on number 6. Okay.
I would.
Anyway, let's just start going through these, and when we get there, I'll tell you what I would do. Or you tell me what you would do. Number 4, what would you do?
Factor.
Yeah, that looks like an easy MA bottoms up type question. So 2 numbers that multiply to 14 and add to -9.
-2.
So x minus 7, x minus 2 equals 0.
whoa, watch your
We now use the 0 product rule. So x minus 7 equals 0 and x minus 2 equals 0. So up here you get positive 7 as a solution. Back here you get positive 2 as a solution.
I have that answer.
Any questions? All right. Number 5. What did you guys do?
Accurate. Subtract 11
Oh, no.
from both sides.
I tried to put it to 0.
I did MA.
I add 3.
I did
I did
MA.
Okay.
You got to do MA.
So I would not use MA on this one because we don't have an x square, or we don't have an x term. So when you, hold on, let me think about it. When you subtract 11,
Dang, I'm stupid.
you get, you can factor, when you subtract 11 from both sides, you get 7x squared minus 14 equals 0. So you'd factor out a 7. And then you could use dots, right? This is not the way I would do it. So if you did it a different way, don't give up just yet. And then 0 product rule, you'll get positive 1 and negative 1.
Should it be -2?
Oh,
Why?
yeah, this doesn't work. Thank you. I was like, how is this both working? Yes, you'd get, and then that's not a difference of squares. Well, you could do it with a square root. I wouldn't do it this way.
What the heck is going on?
I don't know. I'm just messing up.
That's how I did it.
Did you get plus or minus square root 2? Okay. So the way I would do that, and I was like, how is this working out both ways? The way I would do it, since there's no x term, there's only an x squared term, I would get everything away from the x squared and then take the square root of both sides. So I would...
I was supposed to get plus or minus rec 2.
Mm-hmm.
What? I just erased it. I thought it was wrong.
You can't take the square root of 14.
Well, you don't take the square root until you have the x squared part by itself. So you get x squared equals 2. And then, yeah, take the square root of both sides. Anytime you take the square root of both sides, you get a plus or a minus. So you could do dots. It just doesn't work out as neatly as I originally thought it might. My bad. Sorry. Difference of 2 squares, factoring. I would do, if you don't see an x and you just see an x squared, I get everything away from the x squared. Like on number 6. Do you see how there's an x squared?
Yeah.
I would get everything away from it. So what do you, we could divide both sides by 3.
Yeah.
So x squared minus 9 equals what? 27?
That's what I got.
Okay, then what?
And then you add 27.
You had 9.
Add 9.
I mean, that's what I meant, yeah.
What is that, 36? Okay.
X equals 6.
X equals plus or minus 6.
Same thing.
Not the same thing. If you just had 6, you'd lose half the points because you only have half the answers. Maybe minus 1. Depends on my mood when I'm grading these. Okay. Can we fit 7 up there, or do I need to scroll?
Yeah, we can put 7.
Yeah, 7 is it's an x squared x constant equal to 0. That's like perfect MA, hopefully. Maybe not, we'll see. So 16, negative 8, x minus 4 and x minus 4. Okay, so 0 product rule, x minus 4 equals 0 twice. But what do you get both times? 4. So you only need one answer on that one. All right. Questions? Number 8. Ideas? Add 7. We're doing number 8. So on number 8, there's only an x squared term. There's no x term. That's where I would get everything away from the x squared and take the square root. So what is that? 72? What is
65 plus 7?
72? All right.
And then you divide by 4.
Uh-huh.
What's 72 divided by 4?
Okay, so here's where it gets a little tricky. You can't leave your answer square root 18. You can't leave your answer plus or minus square root 18. You got to do a tree.
X equals plus or minus 3 root 2.
Very good. You guys are good at those radicals. Okay. What do you want to do on 9?
I did the multiply add.
Oh, hold on.
No. We want to factor that model.
Hold on. Sorry, I hit the wrong button. There we are.
The multiply add.
We can try factoring. Sure. This would be where you got to make sure you divide by your lead coefficient. So we want 4 times negative 15 is negative 60. Add to 28.
Negative 30 and negative 2.
Negative 2 and positive 30. So I'm going to do x plus 30 and x minus 2. Don't forget the bottoms up trick. You got to divide both of these by 4. The lead coefficient is 4. But then you, so 15 over 2 and 1 over 2. And then we call it bottoms up because you got to kick the bottom up when it doesn't simplify all the way to give you a whole number. So 2 plus 2x plus 15. And 2x minus 1. And if you're like, I feel like I lost it somewhere in there, double distribute, and you'll end up right back here if you did it right. If you didn't do it right, then you won't, and then you'll know to start over. Not done yet. Zero product rule. So 2x plus 15 equals 0. And 2x minus 1 equals 0. So you subtract 15, divide by 2. Negative 15 over 2 is one solution. Positive 1/2 is the other. Okay, so put 5 on the other side, so add 5.
Yeah.
Plus 5.
So
Yeah, now you can multiply add it.
okay, so MA would probably be my go-to. I cannot think of anything that multiplies to 5 and adds to 10. No.
Yeah, what?
So any, yes,
Negative B.
yeah, yep. Anytime you have lost all hope,
Negative B plus or minus, what is that?
and I'm gonna write it just,
Quadratic formula.
Oh my god.
yes.
That's what I did too, so let's see.
This is the when all else fails, I gotta do it. But this is similar to the idea of factoring. You have to be in this certain form to do this, okay? You can't pick out A, B, and C until you're in standard form equal to 0, okay? So, negative B is negative 10 plus or minus the square root. B squared is going to be 100. 4 times 1 times 5 all over 2 times 1. So it's going to be
20, negative 28.
so negative 10 plus or minus square root 80
So yeah, you can do
over
negative
2.
5 plus or minus.
Okay, now square root 80, I'm going to write off to the side somewhere. Because you can do like 8 and 10, 2, 5, 2, 4.
So we do 4 root 20.
Okay, so right now this is negative 10 plus or minus 4
So it'd be 4 root 5.
square root 5 over 2. One more before questions. Do you see how all of these numbers are even?
Yeah.
So the final answer would be negative 5 plus or minus 2 square root 5 over 1, but we don't do the over 1 part. So you can also complete the square on this one. I am going to rewrite it with that space. So remember, when you're completing the square, you get the constant on the other side of the equal sign. It's already good to go. Then you divide b by 2 and square it. So dividing b by 2 would be 5, and 5 squared is 25. So you have to add 25 to both sides of your equal sign. When you do that, we can write the left side as m plus 5 squared. The right side as 20. Okay? Everybody still with me? Mm-hmm. Then you can take the square root of both sides. That's when you have to introduce the plus or minus. So on the left side we have m plus 5. On the right side we have plus or minus square root 20. Do a tree for 20. You still get this, same thing. So m plus 5 equals plus or minus 2 square root 5. And then minus minus. We usually write that in front of the plus minus. So negative 5 plus or minus 2 square root 5. Don't actually do like the plus minus. Like this is definitely not negative 7 square root 5 or anything like that.
Why do you do negative minus 1?
Oh.
And so that's the answer there.
Yeah, that's the same thing we just got, right? So those are the 2 ways to solve that one. I don't think any of the other methods work. So on that one you can complete the square. Or you can use the quadratic formula. All right, so technically the section above, you could avoid one method completely. Like you could never complete the square and still get all the right answers. You could never use the quadratic formula and still get all the right answers. I don't know why anyone would never factor. That's the easiest one. So here I'm forcing you for at least one problem to do all the methods. Okay? So how would I factor this? Okay. Multiply to negative 21. Add to negative 4. What are the magic numbers? Negative 7 and plus 3. Okay, good. Now, the lead coefficient is 1, so you don't have to do like the bottoms up step because dividing by 1 doesn't do anything. So you can go straight to zero product rule. So x minus 7 equals 0, and x plus 3 equals 0. My two solutions are positive 7 and negative 3. Now, the great thing about this section is that you're going to get the same answers for all 3 methods. And if you didn't, you need to keep trying because you made a mistake. Okay? So we are going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we don't get 7, negative 3, then we're doing it again. And we're doing it again. And we're going to keep doing it. And we're going to stay through our lunch hour until we get the right answer. Okay?
Let's do it.
I know. I'm saying like on the test tomorrow. All right. So negative 4. So 4 plus or minus negative 4 squared. So 16 minus 4 times 1 times negative 21 all over 2 times 1. What do you get? What's 16 plus, what is that, 84? 16 plus 84 is 100? Okay. So I have 4 plus or minus 10 over 2.
7, negative 3.
So 4 plus 10 over 2, 4 minus 10 over 2. So I get 14 divided by 2, which is 7. I get negative 6 divided by 2, which is negative 3. Am I satisfied? Yes. Yes, I am.
Are you?
Okay. Questions?
Yeah, can we complete the square?
Let's complete the square. To complete the square, you got to add the 21 to both sides and leave a little space. So minus 4x space equals positive 21. Divide by 2. It's negative 2 squared is plus 4. Oh, good. This is going to be good.
Why?
Because that's a perfect square. All right, square root.
Yeah.
And that's where we introduce the plus minus. So x minus 2 equals plus or minus 5.
What? What did you just do?
I completed the square.
Why? What happened to the negative 4x plus 4?
I rewrote it as x minus 2 quantity squared.
All right, 1 second. Hold on. So you hit them with what?
All right, so I need to add 2. I'm going to write it in front of the plus minus. So x equals 2 plus or minus 5. 2 plus 5 equals 7. 2 minus 5 equals. Boom! I did it. All right, so what form are we in here? Vertex form. So this is negative 2, 3 is my vertex. Shh.
Vortex form.
Chill. All right, so negative 2, 3. And then we graph this just like we did on the front. The only difference is solid, dotted, and then you got to test a point. Okay? So same idea. We're going to do an XY chart.
How can you even tell if it's a dotted line?
So,
Like, I wrote it as a dotted line. You can't even tell.
oh, I can tell. I look real close. All right, so when we plug negative 1 in,
We get 0.
and I just pretend they're equal signs when I'm trying to, don't worry about the inequality till the very end. So when you plug negative 1 in, so that's going to be 1 squared is 1, so 4.
Yeah.
Okay, so negative 1, 4. And it's going to be symmetric, so we'll go to the other side up to 4. And then when you plug 0 in, you'd get 2. 2 squared is 4 plus, 7.
How do you know you get 7?
Yes. So when you plug 0 in, That would be 2 squared, which is 4, and then plus 3 is 7.
Ooh.
Okay, this is going to be a dotted line
Killed him.
because it's an or equal to, and then we test a point. So can you please keep your outburst to a minimum? We have 8 minutes. Okay, so I'm going to test a point. When I test a point, I plug in the x for the x and the y for the y. 0, 0 is the easiest test point, okay? So 0 is greater than 4 plus 3. 0 is greater than 7. Is that true? No, so we shade the other part. That was on the outside of the parabola. I'm going to shade on the inside of the parabola. Okay? Now, on number 15, those are both in standard form, so you can do the negative b over 2a, but b is 0 on both of these, right?
B is 2a. Why?
So the x value of each vertex will be 0. Everyone see that? Okay, so the vertex of the first one, I'll do negative b over 2a. What's b?
0.
0. What's 0 divided by 2?
0.
0. When you plug 0 back in, you get 0 minus 1. Negative 1. So the vertex of the first one is at 0, negative 1. Okay? Now I can do an xy. I'll plug in 0, 1. Or not 0, 1, sorry, 1, 2. And I'll get 0 and 3.
That's for the first one.
Mm-hmm. And it's symmetric, so you can fill in the rest of the points.
Whoa.
Sorry, I'm trying to get us done before the end. So I'm going to kind of rapid fire, and then you guys can ask questions. So this is going to be solid. And I'm going to test 0, 0. So 0 is greater than or equal to 0 minus 1. That's true, so I'm going to lightly shade on the inside of that parabola. All right, I'm going to quickly do the other one. Same thing when I go to find the vertex. I'll do all of the second one in blue. When I go to find the vertex, there is no b. So it'd be 0 divided by negative 2. So the vertex is at the point 0 and then positive 3. So there's my vertex. Again, I can plug in 1 and 2. Now here, careful with the algebra. You square the 1, then you make it negative. So it's negative 1 plus 3, which is 2. So I'm at 1, 2, and then I'm at negative 1, 2. When you plug in the 2, you have negative 4 plus 1, which is negative 1. So now I'm out here. This one is solid as well. I can use the same test point 0, 0. So 0 is less than or equal to 0 plus 3. True. So we're just going to shade lightly inside that one, and the overlap is just this little like chunk. All right, that was the rapid fire work for 15. What are your questions? Yes, sir.
So like if that's true, why would it be like shaded on the inside of that one? That's false on number 14.
The test point was true for both of the 0, 0s.
No, but I mean on like at 14, you start shaded on the inside. The test point was 0.
So over here I tested 0, 0 and it was false.
Yeah.
So I shaded the other part of the graph. If 0, 0 is true, you shade the region that includes the 0, 0.
Okay.
If 0, 0 is false, you just shade the other
So
one.
you always plug in 0, 0?
You plug in 0, 0 as long as 0, 0 isn't on the graph.
And then you plug in like 0, 1?
Yeah. Okay, I'm going to scroll real quick. We might not get to the back, but I can upload the back's answer key.
That's not cool, man. That means we
Okay.
have to test back there.
So depending on what they give you here, this is where we have to find the A, remember? So for number 16, I would use vertex form. And you plug this in for H, this in for K, this in for X, this in for Y. Solve for the A, rewrite it. Same thing on 17. But since they gave us the intercepts, I'll use intercepts form. P, Q, X, Y, find the A. Boom. All right. So this is going to be 5 equals A times 4 minus 6 squared plus 1. That's going to be negative 2 squared, which is 4. So I'm getting A equals 1. And then we rewrite it with 1 in for the A. And then H and K as well. So that's the answer on that one. Same thing on the next one. So is that a negative 2? I covered it up. Yep. So negative 2 equals A times 2 minus 1 and 2 minus 8. So I'm getting A equals 1/3. So it'd be Y equals 1/3 X minus 1 X minus 8. All right, I am going to put the key up for the backside if you want to stick around and watch that. If not, I'll upload it to Google Classroom.